Hi everybody, this Math-172 review for Test 2 is brought to you by the ILC. So in problem number 5, we are asked to verify a couple of things. So there are two parts, A and B. So problem 5A asks us to verify sine x plus cosine x over secant x plus cosecant x is equal to sine x times cosine x. So the first step is always to change anything that's not a sine or a cosine into sines and cosines. So we have sine x plus cosine x over 1 over cosine x plus 1 over sine x equals, we hope, sine x cosine x. Well, we have fractions in our denominator, so it would be good to get a common denominator. So that's sine x plus cosine x over cosine x sine x. So here we multiply by sine x plus cosine x. Oh, interesting. So when you're dividing by a fraction, you can always flip the denominator and multiply. So we've got sine x plus cosine x times cosine x sine x over sine x plus cosine x. Now again, guys, we're just working on the left-hand side, trying to make it look like the right-hand side. And now this whole term, sine x plus cosine x, cancels with this term, sine x plus cosine x. And we're left with our left-hand side being cosine x sine x. Does that equal sine x cosine x? In fact, it does. So we have just verified. So again, you only mess with one side to make it look like the other. So that's problem 5A. So we got problem 5B. Which also asks us to verify. So we want to know that the cosine of negative theta over 1 plus the sine of negative theta equals secant theta plus tangent theta. Okay, well, let's see here. We must examine what's going on with sine and cosine. And again, I'm going to tell you to sketch it. So if we graph sine as a function of theta, we know sine starts at 0, goes up to 1, comes back down to 0, goes down to -1, and comes back to 0. Okay, so this is how sine goes. Notice that if you go to some value here, the sine of theta is a positive number. But if you go the same distance on the other side, the sine of negative theta is in fact the opposite of sine theta. Yeah? Because this one is positive and this one is negative. That's good to know. Well, what's the case with cosine? Well, we're just going to draw it. If we're looking at cosine as a function of theta, at 0, cosine has a value of 1. And then here, 0. And then here, -1. And then here, back to 0. And here, back to +1. So, like this. And like that. Okay? So if we come to some positive value theta, or go to some negative value negative theta, we can see that the cosine of negative theta is the same as cosine theta. So guys, they're different. This is an odd function, this is an even function. But if you're ever at a loss on a quiz, just draw a little graph. All right, so knowing that, let's simplify this. Cosine of negative theta is just cosine theta. And then sine negative theta is minus sine theta. So this reminds me of the identity of 1 minus sine squared equals cosine squared. So I'm going to multiply the top and the bottom by 1 plus sine theta to make this look a little better. So that gives us cosine theta plus cosine theta sine theta over 1 minus sine squared theta. Oh, but I recognize that. I know what that is. 1 minus sine squared is just cosine squared. So again, we're working with our left-hand side. We've got cosine theta plus cosine theta sine theta divided by cosine squared theta. Okay, so cosine over cosine squared gives me 1 over cosine. And then one of these cosines cancels, and we get sine theta over cosine theta. So this becomes 1 over cosine is secant theta, and sine over cosine is tangent theta. We have messed with the left-hand side until it matches the unadulterated right-hand side. We have verified. And that is the end of problem 5.